Hi, I'm Mike Martin with Trutegra, and we're about to head over to an off-site test lab that we have set up to demonstrate some physics and sizing of a new project we're working on. The facility we're heading to now is an off-site warehouse that we've rented to construct a physical mock-up of the equipment we're working on a current project. We don't have the space in our normal office to do this, so we utilized rented space to have some extra freedom. Reason for doing this is the cycle times and constraints of this project are such that we don't have time to sort this out in the field, and we have to be absolutely certain of the software and the timing of it before we make it to the site. So the goal here is to finalize all of our code, finalize all of the piece of this project, and start up a project on the first go around in 2 days and have it work exactly as designed. So as many of you know, we have a full-size crane in our lab in Charlotte that we do a lot of our development and testing on. This project created a need for something that's much faster than the original crane we built. The crane behind me is capable of 1.6 meters per second, which is well beyond the customer requirement of 1.2 meters per second. This crane is also allowing us to test a couple new technologies for use on this project and others, including radar positioning and radar level sensing. The radar positioning system that we have behind me is operating in the 60 gigahertz band and it offers millimeter position accuracy. The level probe that we're using in this is also in the radar band. However, this one is 80 gigahertz and allows us to see levels in a very, very dusty environment.
Hey guys, my name is Matthew McGrimis. I'm a project engineer here at Trutegra. What I'm doing here is I'm taking this crane you see behind me and I get the honors of testing it out before it gets on site. So if we have any kind of process to figure out or any kind of sensors to work on, what we get to do basically is set them up here on site, usually at full speeds or the speeds of the cranes at site, and we can do all our testing here, make sure we get all the kinks worked out, make out any of the code we need to figure out. We get to do it before it gets into production environment, because obviously these environments are non-stop 24 hours, so we want to make sure everything that we can get done before is done here, and then on site usually goes smoother with a nice easy startup.
Hi, I'm John Humphreys. I'm a computer engineering student at the University of North Carolina here in Charlotte. I'm currently interning with Trutegra, and being able to work on this full-scale crane has been a very awesome experience. I've gotten a lot of exposure to things that you wouldn't normally get unless you actually went onto a job site and entered production. So this has been very great for me, being able to see how to program the cranes and how to get them to move properly and tune them so that they work efficiently and do what they're supposed to do every time.
So we're up here at crane level to talk a little bit more about the sensors we're testing. We use this opportunity to do a baseline comparison between a new radar-based position system and an older laser-based technology. Some of our projects have some very demanding environmental concerns, namely steam, fog, dust, and we're seeing a shift towards radar technology as a way to overcome these obstacles. The value with a setup like this, it allows us to get performance characteristics of both technologies during the same run so that we know how to tune our software to handle the slower update rates of some of these technologies. All right, thanks for joining me on our tour of our off-site test facility, but now me and the guys got to get back to some real work.